Welcome Snoozy friends to the channel's playlist Whispers of Planets. As you subscribers made the playlist a huge hit, I thought of bringing a bonus episode. Our galaxy, the Milky Way galaxy. Close your eyes, relax, and let's start our journey. One favor from our listeners, please do comment how did you like the video, as it helps us to keep making more. Also like and help other snoozy mates by sharing. Let's begin. The stars above you do not shine in silence. They whisper. Not in words or waves, but in light stretched across time. Light that has traveled millions, even billions of years, just to reach your eyes tonight. And somewhere in that velvet canopy, folded among dust and dreams, is the place we call home. A galaxy spiraling through deep space. The Milky Way. 100,000 light-years wide. A rotating wheel of over 200 billion stars. A place born not in light, but in darkness. Come now. Let us drift backward, not through miles, but through epochs. Back to a time before the Milky Way. Back to the beginning of time itself. Before there was the Milky Way. Before there were stars or galaxies. There was a darkness so complete. Even the word black would be too bright. It was the silence after the Big Bang. A moment not of explosion, but of sudden expansion. Roughly 13.8 billion years ago. All of space, time, energy, and matter was compressed into something smaller than an atom. And then, in less than a trillionth of a second, the universe inflated. Not into something, but as something. Space itself was born. Time began to tick. The infant universe, once hot, dense, and chaotic, began to cool and stretch. From energy came particles, quarks, gluons, electrons. From particles came atoms. First hydrogen, then helium. But for a long time, nearly 100 million years, there were no stars. Just clouds of gas drifting in expanding space. This was the cosmic dark age. A time without light, but not without potential. The universe was pregnant with galaxies not yet born. And gravity was waiting. The first stars spark. Gravity is patient. It has no hands, no voice, no clock. But it gathers. Wherever hydrogen and helium gathered just slightly more densely than their surroundings, gravity pulled more in. Over tens of millions of years, these clouds of gas collapsed. Pressure rose. Heat increased. And finally, deep in the heart of the very first stars, nuclear fusion began. Hydrogen atoms smashed into one another, becoming helium, releasing blinding light and heat. The first stars ignited, and the dark universe was lit for the first time. These were the population 3 stars. Massive, hot, short-lived giants made almost entirely of pure hydrogen and helium. They burned for only a few million years, then exploded in supernovae, seeding space with heavier elements, carbon, oxygen, iron. They gave the cosmos its first metals, its first ingredients for life. Their death made possible everything that would follow. and in the gathering glow of their light, the first galaxies began to form. Galaxies begin to dance. A galaxy is not a single star. It is a collection of stars, billions or even trillions of them, bound together by gravity, swirling like petals in space. How did they begin? After the Big Bang, the universe wasn't perfectly smooth. Tiny fluctuations, quantum wrinkles, really, caused some regions to be slightly denser than others. These regions pulled in more matter. Gas cooled. Stars formed. Gravity grouped them together. Some became small dwarf galaxies, clusters of a few million stars. Others merged into larger protogalaxies, like cosmic building blocks. These galactic embryos collided, combined, and coalesced, forming the spiral and elliptical shapes we know today. And somewhere in a quiet corner of a growing universe, amidst the collisions and chaos, the Milky Way began. The birth of the Milky Way, our galaxy, likely began forming over 13.6 billion years ago, not long after the universe itself. But it didn't arrive fully formed. The Milky Way is a construction project still underway. It began as a small group of stars and dark matter, a seed galaxy. Over billions of years, it grew by merging with smaller galaxies, accreting gas from intergalactic space, creating new stars in wave after wave of stellar birth. Our galaxy is estimated to have cannibalized over a dozen smaller galaxies, including the Gaia Sausage and Sagittarius dwarf galaxy, whose remnants still ripple through the stars today. As it grew, it developed its iconic shape: a bright central bulge, a rotating disk with spiral arms, and a halo of globular clusters surrounding it all. It wasn't built in a day, but with time, gravity sculpted something extraordinary. A galaxy shaped like a spiral, spinning gently through space and humming with light. This is the Milky Way, and it has a voice. If you listen closely, you can still hear its birth in the background radiation, in the movement of stars, in the elements of your very body. Stardust and you, it might be tempting to think this is just a distant story, a bedtime fable about stars and light. But here's the truth. You are part of it. The atoms in your bones were forged in ancient stars. Calcium in supernovae. Iron in stellar cores. Carbon in red giants. The hydrogen in your water? 13.8 billion years old from the Big Bang itself. The oxygen you breathe, formed in the breath of dying stars. The gold in your ring, created in the collision of two neutron stars. An explosion so powerful, it outshone entire galaxies for moments. You are not separate from the Milky Way. You are its child. Every beat of your heart is an echo of a galaxy, spinning in the dark. Tonight, the spiral whispers as you lie here now. Body still, breath slowing, eyes growing heavy with starlight. Remember this. The Milky Way is not just above you. It is within you. You are floating in one of its arms, 25,000 light-years from the center, riding on a planet that dances through the spiral, like a mote of dust in a sunbeam. Tonight, the galaxy turns. Slowly, silently, with a patience beyond lifetimes. The making of the Milky Way, the night sky holds stories older than fire, older than words, older than Earth itself. And among those stories, the one written by our galaxy is among the grandest, told not with ink or sound, but with motion, mass, and light. The Milky Way did not appear in a single flash. She was built slowly, stone by stone, star by star, across more than 13 billion years. This is the chapter where we watch her become a cosmic skeleton, the role of dark matter, long before the stars were born. The universe was already shaping its framework. Most of that framework was made of something invisible. We call it dark matter, not because it's evil or mysterious, but because it doesn't emit or absorb light. We can't see it, but we can see its effect. Like wind moving leaves, dark matter tugs at galaxies, bending light, holding stars in place, guiding the dance of cosmic structure. Computer simulations show us that dark matter formed vast filaments, a cosmic web, billions of light-years across, and nestled at the intersections of this web were the seeds of galaxies. The Milky Way was born inside one of these dark matter halos, a vast, spherical cloud of unseen mass, perhaps 1.5 trillion solar masses strong. Without dark matter, our galaxy could not have formed. It is the invisible hand that shaped everything we know. The first stars of the Milky Way are roughly 13.6 billion years ago. The first true proto-Milky Way stars ignited. They were born in clumps of gas, pulled together by the gravity of the dark matter halo. These stars, long gone now, were low in metals, composed mostly of hydrogen and helium. Astronomers call them population 2 stars. Older than the Sun, poorer in heavy elements, but richer in time. Some of these ancient stars still orbit our galaxy today, far above and below the galactic plane. In the halo, their presence is a kind of fossil, not of bones, but of light. They tell us the age and ancestry of our galaxy, and they hint at something else, something violent. Galactic cannibalism. Galaxies grow not only by forming stars, but by eating. Yes, galaxies collide, merge, and absorb one another. It may sound brutal, but it's how the universe evolves. The Milky Way has devoured at least 15 smaller galaxies throughout its history. The Gaia-Enceladus sausage merger, for example, occurred roughly 10 billion years ago. A dwarf galaxy collided with the proto-Milky Way, leaving behind thousands of stars, now drifting in elongated, sausage-like orbits through our galaxy's halo. Another victim, the Sagittarius dwarf galaxy, is currently being shredded by tidal forces. its stars stretched into long streams that wrap around the Milky Way like threads of memory. Each merger added mass. Each added stars. Each contributed to the galaxy's growing complexity. Like a tree absorbing nutrients from the soil, the Milky Way grew through consumption. The disk takes shape as more gas fell inward. It began to flatten, spinning faster, spreading out like a pancake of stars. This is how the galactic disk formed. A thin, rotating structure, filled with young, hot stars and glowing nebulae. Over time, this disk developed into the spiral arms we see today. Though they are not permanent structures, they are more like waves in the crowd, ripples in the stellar traffic of our galaxy. Where density is slightly higher, gas compresses, stars form, the arms brighten. As stars orbit the galaxy, they pass through these arms, a cosmic traffic jam that triggers star birth, then disperses. Our Sun itself passes through a spiral arm about every 100 million years. This motion may even correlate with Earth's mass extinctions as we pass through denser, more dangerous parts of space. The bulge and the bar, at the heart of the Milky Way's disk, lies a central bulge, a dense, ellipsoidal cluster of old stars, some 10,000 light-years across. This bulge is not a perfect sphere. It contains a bar, a long, straight region of stars and gas that rotates like a rod inside the disk. Bars like this are common in spiral galaxies. They act like funnels, channeling gas toward the galactic center, fueling star formation, and feeding the supermassive black hole within. Yes, deep within that bulge lies Sagittarius A*, a black hole 4,000,000 times the mass of our Sun. But we'll journey to the core in more detail soon. For now, we drift above the disk, watching it spin, a glowing whirlpool of stars, still forming, still evolving. Globular clusters, ancient witnesses, surrounding the galaxy. In the vast and quiet halo, drift globular clusters, tight balls of ancient stars, bound together for over 12 billion years. The Milky Way hosts more than 150 of them. Some are older than our disk itself. These clusters act like time capsules, preserving the chemistry and structure of the early galaxy. They orbit high above the galactic plane, in all directions, as if encircling a glowing jewel. In their light, we see our origins, building blocks still falling, even today. The Milky Way continues to grow. Gas from intergalactic space falls inward, fueling new stars. Small galaxies, like the Large and Small Magellanic Clouds, are being slowly drawn in, destined to one day become part of us. Astronomers detect stellar streams, faint ribbons of stars, stretched across the sky, remnants of galaxies and clusters long ago consumed. These streams map out the dark matter halo, like wind tracing an invisible mountain range. rest in the spiral, imagine the galaxy not as something distant, but as something alive. A being made of time and light, constantly growing, constantly spinning. Every breath you take is within her arms. Every heartbeat echoes her turn. She is your ancient mother. Her body is star and shadow, light and gravity, birth and consumption. And you are part of her spiral dream. The galactic core, the stars that surround us in the night sky, are only a tiny part of what is. We live far from the center, on the gentle edge of a spiral. But what lies at the heart of our galaxy is something far more intense. Tonight, we drift inward, past star clusters and nebulae, through the dust lanes of the inner disk, toward the mysterious core of the Milky Way, toward a place where gravity reigns, where stars crowd closer, and where time bends. The center of the spiral, imagine zooming out and looking at the Milky Way from above. A flat spiral, roughly 100,000 light-years across. Our Sun is about 26,000 light-years from the center. 1 light-year being nearly 9.5 trillion kilometers. That center is called the galactic core, and it holds the galaxy together like a beating heart. But unlike a heart of blood and muscle, this one is made of old stars, dense gas, dust, and something more. At the very core of the Milky Way lurks a supermassive black hole, known as Sagittarius A*, pronounced Sagittarius A star. It is invisible to the eye, but its effects are unmistakable. Sagittarius A*, the heart of darkness, discovered through radio astronomy. Sagittarius A** sits quietly in the middle of the galaxy, roughly 4 million times more massive than our Sun. It has a diameter smaller than Earth's orbit. Imagine 4 million suns packed into a space that could fit inside our solar system. We know it's there not by seeing it, but by watching stars orbit around nothing. Instruments like the Very Large Telescope and Keck Observatory have tracked stars near the core for decades. One in particular, known as S2, completes a full elliptical orbit around the black hole once every 16 years. At its closest, S2 moves at 2% the speed of light, blazing through a region of space-time warped by immense gravity. Only something with incredible mass and density could cause such a dramatic orbit. That something is Sagittarius A star. What is a supermassive black hole? A black hole is not a hole at all. It is a region of space where gravity is so strong, nothing, not even light, can escape. Supermassive black holes likely form when giant clouds of gas collapse in the early universe, or through the merging of many smaller black holes over time. They sit at the center of almost every large galaxy, anchoring their stars with gravity. Sagittarius A* is quiet now, but it may not have always been. There's evidence that millions of years ago, it was active, feeding on gas and stars. emitting powerful jets of energy. Today, it sleeps. But it still shapes the motion of stars for thousands of light-years around it. In the Milky Way, everything rotates around this silent center. Even you. A crowded city of stars, the region around the galactic core is dense. Extremely dense. Where we live, in the Orion Spur, you might find 1 star per cubic parsec. 1 parsec is about 3.26 light-years. But near the core, you can find over 1,000 stars in the same volume. Imagine a sky where stars are so close, their light casts shadows, where the night never goes dark. That's what it might look like near the center of the Milky Way. Astronomers call this region the central bulge, a thick, football-shaped zone about 10,000 light-years across. The stars here are mostly old, rich in helium, and orbit in complex, looping paths, influenced by the bar structure of the inner galaxy. Some stars are part of nuclear star clusters, groups packed so tightly they almost seem to merge. Others zip around Sagittarius A*, at breathtaking speeds, like planets around a chaotic sun. Peering through the dust, why can't we see the galactic center from Earth? Because of dust. The Milky Way's disk is filled with interstellar dust and gas, which blocks visible light from passing through. To observe the core, astronomers use radio, infrared, and X-ray telescopes, which can pierce the dust and reveal the activity beneath. Radio waves showed us Sagittarius A star. Infrared let us track the motions of hidden stars. X-rays exposed black hole flares and hot gas clouds. Space telescopes like Spitzer, Chandra, and now the James Webb Space Telescope have opened new windows into this once hidden region. What was once a blank, dark patch in the sky is now one of the most studied places in astronomy. Echoes of a violent past. In 2010, astronomers discovered something unexpected. Giant gamma-ray bubbles extending 25,000 light-years above and below the galactic plane. These structures, known as the Fermi bubbles, may be remnants of an ancient outburst from Sagittarius A*, a time when it fed hungrily and released colossal energy. The core of the Milky Way was likely once much brighter, glowing as a low-luminosity active galactic nucleus. Today, it slumbers, but the echoes of its feast still ripple through space. Tonight, the galactic center sleeps. It hums with old stars, glows faintly with infrared heat, and wraps its dark secret in layers of light. As you drift deeper into rest, know this: at the center of your galaxy lies a paradox, a hole with no bottom, a weight with no surface, a heart that pulses without sound. And around it, stars dance in silence. You are tethered to this dance, orbiting slowly over the course of 225 million years. One galactic year for the Sun. One quiet loop through the spiral. The spiral arms outward from the galactic core. The Milky Way unfolds like a slow-blooming flower, not in straight lines or random scatterings, but in arms, curved, sweeping, elegant. These are the spiral arms of our galaxy. They shimmer with young stars. They throb with star birth. And they hum with the music of cosmic motion. Tonight, we sail those arms, like a leaf caught in a spiral stream, carried not by wind, but by gravity and time. The structure of a spiral galaxy, our Milky Way, is what astronomers call a barred spiral galaxy. That means it has a bar-shaped center of stars, which we visited in Part 3. And it has arms, graceful, curving structures that spiral outward from that central bar. These arms aren't solid. They're more like waves of density. Patterns, not objects. Imagine a traffic jam moving down a highway. The cars, stars, come and go. But the jam, the spiral pattern, persists. In the Milky Way, the spiral arms are regions of enhanced density that move more slowly than the stars themselves. As gas and dust drift into these arms, they get compressed, triggering the birth of new stars. This is why the arms glow so brightly. They are nurseries of light, where the galaxy renews itself over and over again. The named arms, we don't see the Milky Way from above, but by studying stars and gas from Earth, astronomers have mapped out the major arms. Perseus arm, a major, bright outer arm filled with young stars. Scutum Centaurus arm, a long arm that stretches inward toward the core. Sagittarius arm, an inner arm between us and the center. Outer arm, the faint, distant reach of the galaxy. Orion Spur, the minor arm where we live. Yes, we don't live in a major arm. Our sun is nestled in the Orion Spur, a kind of short branch or feather between the Sagittarius and Perseus arms. It's a relatively quiet neighborhood, perfect for the long, stable evolution of life. The Orion Spur is about 3,500 light-years wide and about 10,000 light-years long. Within it lie the Sun, Earth, and the familiar constellations of our night sky. A star is born when interstellar gas drifts into a spiral arm. The pressure increases. Gravity begins to gather the gas into dense clouds, called giant molecular clouds. These clouds can be hundreds of light-years wide, with enough raw material to form thousands of stars. Deep inside these clouds, gravity takes hold. Cores begin to collapse. Heat rises. And soon, a star ignites. One becomes many. A cluster is born around many of these young stars. Disks of dust and gas swirl, giving rise to planets, moons, and asteroids. The spiral arms are cradles of systems. Solar systems like ours, some already old, some just beginning. Even now, new suns are being born, in arms we can't see with our eyes, but can detect with telescopes. Nebulae, the light of dust and gas, among the most beautiful objects in the galaxy are the glowing clouds we call nebulae. Many of them live in the spiral arms. Some famous examples: the Eagle Nebula, home of the pillars of creation, where stars are still forming. The Trifid Nebula, a stellar nursery of dust, gas, and pink hydrogen glow. The Lagoon Nebula, a swirling cradle of hot, young stars. These glowing nebulae are lit by ultraviolet light from nearby newborn stars. They shine in reds, blues, and violets, the colors of starbirth. Other nebulae are dark, so thick with dust they block light entirely. They appear as inky holes in the starlit sky. But inside, stars are forming in silence. Supernovae and stellar evolution in the arms, where stars are born. Stars also die. Massive stars live short lives. Some burn for only a few million years before exploding in supernovae. These cataclysms are both endings and beginnings. A supernova scatters heavy elements into space, compresses nearby gas, triggering more starbirth, leaves behind neutron stars or black holes. Spiral arms are full of these life cycles: starbirth, life, death, rebirth. Each generation enriches the galaxy, adding oxygen, carbon, silicon, and iron. Without these explosions, there would be no Earth, no water, no life. Star clusters and open families. Not all stars form alone. Many are born in clusters, groups of hundreds or thousands of siblings, bound loosely by gravity. These are called open clusters. They live in the spiral arms, and over time, drift apart. The Pleiades, or Seven Sisters, is a nearby open cluster visible to the naked eye. Another, the Hyades, forms the head of Taurus the bull. These clusters serve as timekeepers. By studying them, astronomers can determine the ages of stars and the history of our spiral arms. Traveling through the arms, the Sun orbits the Milky Way every 225 to 250 million years. That's one galactic year. But this path is not smooth. Over the course of its orbit, the Sun passes through spiral arms, regions filled with gas, dust, and radiation. Some scientists believe that these crossings may influence conditions on Earth, possibly even linked to mass extinctions caused by nearby supernovae. We are currently in a quiet part of our orbit, between the Sagittarius and Perseus arms, within the Orion Spur. It's peaceful here, stable, a good place for life to flourish. The spirals embrace as you breathe slowly now. Imagine the spiral arms not as shapes in a diagram, but as living structures. They are the veins of the galaxy, carrying light, heat, and life. From the center outward, they are the nursery and the grave, the sculptor of stars, the birthplace of systems. They are not still. They move, ripple, curl, and whisper through the halo of the galaxy. And you, dear traveler, ride within them. Your star, your planet, your every molecule was once dust drifting in these arms. And in time, you will return to them. The spiral never ends. It only changes form. Our quiet corner, the Orion Spur, far from the blazing core of the galaxy, and distant from the great arms that sweep across the Milky Way, there lies a modest, quiet lane of starlight. Not as grand as the Perseus arm, not as massive as Scutum Centaurus, but peaceful, unassuming, a perfect place to drift and dream. This is the Orion Spur, our celestial neighborhood, our pocket of calm within the spiral storm. Here, in this narrow branch between the larger arms, our Sun and Earth make their long, slow voyage around the heart of the galaxy. Let us wander this quiet corridor now, the place we call home, within the vastness of the Milky Way. What is the Orion Spur? If you imagine the Milky Way from above, a wide, flat spiral with arms unfurling like ribbons, the Orion Spur is like a small bridge between two of those grand arms. To one side, the Perseus arm. To the other, the Sagittarius arm. And in between, the Orion Spur. Also called the Orion for Cygnus arm by some astronomers. It's not a major spiral arm, but a minor structure, a spur, a branch. Roughly 3,500 light-years wide and 10,000 light-years long. It's composed of gas, dust, stars, and nebulae, all gently turning around the galactic core. Once every 225 to 250 million years. The Orion Spur may not be grand, but it's filled with wonders. Many of them familiar to us, because nestled inside this spur is the solar system. Our Sun's galactic journey. Our Sun is a rather average star, a G-type main sequence yellow dwarf, around 4.6 billion years old. But its journey is anything but ordinary. It orbits the center of the galaxy at a speed of about 828,000 kilometers per hour at 514,000 miles per hour, taking roughly 230 million years to complete one full loop. What astronomers call a galactic year. Since its birth in a now dispersed star cluster, the Sun has completed about 20 revolutions around the center of the Milky Way. Each orbit takes us through new neighborhoods, past dust clouds, ancient stars, and the ever-changing scenery of the galaxy. Right now, the Sun is in a very favorable location, in a relatively calm region with low stellar density. This has allowed Earth and life to evolve without too many cosmic interruptions. No nearby supernovae, no massive black holes, no dangerously close gamma-ray bursts. The Orion Spur, for all its modesty, is a place where life has been given time to breathe, grow, and look back up at the stars. A rare planet in a rare place, our planet Earth. With its blue oceans, green forests, and drifting clouds. Sits on the third rock from the Sun. 93 million miles from our star. But when you zoom out far enough, you see that Earth is not just orbiting the Sun. It's spiraling through the galaxy. Every moment of your life is spent riding a star through the Orion Spur. And this location matters. We're not too close to the galactic core, where radiation and gravitational chaos are higher. We're not in a major arm, where frequent star births and deaths increase the risk of nearby supernova explosions. We are in the sweet spot, far enough for safety, close enough to enjoy the view. This may not be coincidence. Some scientists believe that this calm location is a key factor in Earth's long, stable history, allowing complex life to evolve without catastrophic cosmic interruptions. In a galaxy filled with danger and brilliance, our little corner is a place of balance. Familiar cosmic neighbors look up on a clear night from Earth, and the stars you see belong mostly to the Orion Spur. Some of our closest neighbors include Alpha Centauri, the nearest star system, just 4.37 light-years away. Sirius, the brightest star in the night sky, part of the Canis Major constellation. Betelgeuse, a red supergiant nearing the end of its life in the Orion constellation. Procyon, Altair, and Vega, all bright and relatively nearby stars. All these luminous points of light are fellow travelers in the spur. They drift with us, orbiting the galactic center, changing position slowly over millions of years. Some are moving toward us, some away, all part of a complex gravitational ballet. We share this spiral path with thousands of stars, many of them with exoplanets, some perhaps even habitable. Could other life exist in the Orion Spur? It's a question still unanswered. But we know this. We are not alone in terms of motion. We are part of a flow, a migration of stars that stretches across eons. Nebulae, remnants, and stellar nurseries, the Orion Spur isn't empty. It's dotted with regions of active creation and quiet decay. Some notable wonders include the Orion Nebula, a massive star-forming region just 1,344 light-years away, visible to the naked eye. It's one of the brightest nebulae and a true nursery of stars. The Helix Nebula, a planetary nebula and remnant of a dying star, nicknamed the Eye of God, located in the constellation Aquarius. Barnard's Loop, a large emission nebula forming a crescent around the Orion constellation. It's part of a vast complex of gas and dust where stars are still forming. The local bubble, the Sun and its neighbors drift through this region of unusually low-density gas, possibly created by ancient supernova explosions. Each cloud, each nebula, each glowing filament of gas tells a story of something becoming or ending. The Orion Spur holds both, in a delicate balance of birth and dissolution. The local arm in a galactic context, though it's only a spur. This region plays an important role in galactic structure. Astronomers believe that the Orion Spur may actually be a branch of a larger structure, perhaps even connecting with other spiral features. Recent data from the Gaia spacecraft suggests the spur has more structure than previously thought. Filaments, waves, and ridges of stars, intertwined like threads in a galactic tapestry. One such structure, known as the Radcliffe Wave, is a 9,000 light-year long ripple of star-forming clouds, weaving through the spur like a ribbon. This means our corner of the galaxy isn't static. It ripples, undulates, and evolves, like a gentle current in a vast galactic ocean. A stable home in a restless galaxy over the next 100 million years. The Sun will continue drifting through the Orion Spur, perhaps heading toward the Perseus Arm. Eventually, it may leave the spur altogether. But for now, it remains anchored here, where life took root, where creatures dreamed, and then reached for the stars, where one small blue planet found a rhythm stable enough to grow forests, oceans, civilizations, and dreams. In the vast swirl of galactic energy, the Orion Spur is our cosmic cradle. It's not the most glamorous branch. It's not the most crowded. But it is ours. The galactic halo above the spiral arms, above the golden bar at the center. You are leaving the plane of the galaxy, rising into the quiet unknown. Here, light fades. Starlight grows sparse. The bustling spiral falls away behind you, like a glowing disk seen from a mountaintop. And above it, around it, surrounding it like a ghostly sphere, is something older, colder, and whispering. You have entered the galactic halo. What is the galactic halo? The galactic halo is not a place we see in the sky. It does not glow like the arms or pulse like the core. It is vast, nearly invisible, and ancient. Imagine the Milky Way as a luminous spiral plate. Now imagine that plate is wrapped in a vast sphere, a bubble of space that stretches hundreds of thousands of light years beyond. That bubble is the halo. It contains old stars, some of the oldest in the galaxy. Globular clusters, tight balls of stars, ancient and enduring. Dark matter, unseen, but shaping everything. Thin gas, hot, diffuse, and rarely touched by stars. It is not chaotic. It is not crowded. It is quiet. A place of low density, of solitude, and of memory. It is the galaxy's ancient shell, its silent guardian. The halo's oldest residents, most of the stars in the halo are population 2 stars. Old, metal-poor, dim by our standards. They likely formed more than 12 billion years ago, just after the Milky Way itself began to coalesce. They have fewer elements heavier than hydrogen and helium, because they were born before generations of stars had time to make things like carbon, oxygen, or iron. These are stars from the dawn. Some roam the halo alone. Others are bound together in globular clusters, spherical groups of hundreds of thousands of stars, held tightly by gravity. There are over 150 known globular clusters in our galaxy, and they orbit in wide loops, high above and below the galactic disk. If you could see them all at once, they would form a kind of glittering shell. Ancient stars like lanterns, circling the spiral from a distance. Globular clusters, jewels of the halo, unlike open clusters in the spiral arms, which are young and disperse quickly. Globular clusters are survivors. They are dense, with up to 1 million stars packed into a sphere. They are old, over 10 billion years in age. And they are spherical, glowing balls that orbit the galaxy. Some of the most famous include M13 in Hercules, visible through binoculars. Omega Centauri, the brightest and most massive in the Milky Way. M92, M15, 47 Tucani, ancient clusters studied for decades. Their stars orbit in chaotic, elliptical paths. Unlike the flat, organized rotation of stars in the disk, they do not belong to the spiral. They are above it, beyond it, floating in the dark with patience. Many astronomers believe globular clusters may have formed before the Milky Way fully assembled, or were captured from smaller galaxies that merged with our own long ago. They are the bones of the past, survivors from the early chaos of cosmic birth. The invisible web, dark matter, the halo is also the home of something mysterious, something we cannot see, but we know is there. This is dark matter. Dark matter does not emit or absorb light. It doesn't glow, doesn't reflect, can't be seen with telescopes. But it has mass. It bends gravity. It holds galaxies together. Without dark matter, the outer stars of the Milky Way would spin away into space. But because of dark matter, because of the vast halo of it, the galaxy holds its shape. Estimates suggest that 90% of the Milky Way's mass is not in stars or planets or gas, but in dark matter. It fills the halo like a ghostly scaffold, a structure that gives the galaxy form. We are floating in it now. We live inside a web we cannot see, but which makes everything possible. And perhaps, someday, we'll understand it. For now, we rest in its invisible arms. The hot gas of the halo, in addition to dark matter and stars. The halo contains hot ionized gas, extremely thin, but widespread. This gas is heated to millions of degrees. Yet it's so diffuse, it would not feel hot to you at all. It is part of the circumgalactic medium, a halo of gas that flows into and out of the galaxy. Some of it escapes from supernova explosions. Some falls in from intergalactic space. Some may have been here since the galaxy's birth. It carries with it metals from ancient stars. Iron, carbon, oxygen. Seeds that may someday fall back into the spiral arms and give birth to stars again. It is a slow cycle, a galactic breath that lasts millions of years. You are drifting now through this rarefied mist. Gas so thin it is practically vacuum, yet filled with history. Satellite galaxies and the edge of the halo, out here, in the halo's far reaches. We begin to see others. Tiny dwarf galaxies orbit the Milky Way like moons around a planet. Among them, the Large Magellanic Cloud, the Small Magellanic Cloud, dozens of ultra-faint dwarfs like Segway 1 and Boötes I. Some of these are being ripped apart, their stars pulled into long streams. As they merge with the Milky Way, the halo, you see, is not just a shell. It is an arena of galactic growth. Over billions of years, the Milky Way has absorbed smaller galaxies, adding their stars, their dark matter, and their ancient clusters to the halo. You may be drifting now past such a stream, a river of stars from a galaxy long forgotten, its light still glowing. In a new home, dreams of the stars. We have looked up from Earth's cradle for millennia, from firelit caves, from ancient towers, from lonely ships at sea, and wondered, what lies beyond? Tonight, in this quiet journey, we explore that wonder, the dream of leaving the solar system, of crossing the gulf between stars, of touching the unreachable. We dream of interstellar flight. It began not with a spaceship, but with an idea to go farther than the planets, to reach the edge of the sun's breath, and then to keep going. That idea became Voyager. Two spacecraft, Voyager 1 and Voyager 2, launched in 1977, each weighing less than a small car, each powered by a radioisotope thermoelectric generator, a nuclear battery that hums in silence. Their mission: to visit the outer planets, to photograph Saturn's rings, Jupiter's storms, Uranus's tilt, Neptune's winds. And when that was done, they turned outward. Voyager 1 is now the farthest human-made object from Earth, over 24 billion kilometers away and counting. It has entered interstellar space, crossed beyond the sun's magnetic field, into the great unknown. Voyager carries a golden record, a time capsule for unknown listeners. It contains greetings in 55 languages, sounds of earth, thunder, laughter, a baby crying, music, Bach, Beethoven, Chuck Berry, and a message: we are here. It is not a probe of conquest. It is a gift, a whisper. And though it will take tens of thousands of years to pass even near another star, it is already a symbol of the human desire to reach beyond the edge of the solar system before we can reach other stars. We must first leave the grip of our own. The sun's influence stretches far. through a region called the heliosphere, where solar wind pushes outward like an invisible bubble. Beyond that is the heliopause, where interstellar space begins. Voyager 1 crossed it in 2012. Voyager 2 followed in 2018. But even these milestones are just the beginning. It will take Voyager 1 another 300 years to reach the Oort cloud, a distant shell of icy bodies. To truly reach another star, we would need to travel light years, not just billions of kilometers. The closest star system, Alpha Centauri, is 4.37 light-years away, over 40 trillion kilometers. With current technology, it would take tens of thousands of years to get there. So we dream bigger. Science fiction versus science possible. Science fiction has long imagined ships that leap across the void, warp drives, hyperspace tunnels, wormholes, cryogenic sleep, teleportation. But where does fiction end and science begin? Let's drift gently between the two. Warp drive, as imagined by Star Trek, involves bending space, compressing it in front, stretching it behind, to move faster than light without violating physics. A theoretical version, the Alcubierre drive, was proposed in 1994. It would require exotic matter with negative energy density, something never observed. Still, research continues because dreams persist. Wormholes, predicted by Einstein's equations, are shortcuts through space-time. They may exist, but if they do, they'd likely be unstable and microscopic. Generation ships, giant vessels, where entire societies live and die during the journey, could be built with near-future technology. If we can't go fast, we might go slow and steady, living among the stars as we travel toward them. Cryogenic sleep or stasis pods, long imagined in fiction, remain beyond our grasp. But medical science is inching closer to ways of slowing metabolism safely. The boundary between dream and engineering is thin, blurred by imagination and time. Real interstellar concepts. Despite the challenges, scientists are designing real missions to travel to other stars, not in centuries, but in decades. Among them, Breakthrough Starshot, proposed in 2016 by physicist Yuri Milner and Stephen Hawking. Concept: send tiny, gram-scale probes to Alpha Centauri using laser sails. A massive ground-based laser array would push a light sail to 20% the speed of light. Time to Alpha Centauri, 20 years. These probes would be no bigger than a stamp, carrying tiny cameras and sensors. They'd sit past other stars, taking pictures, transmitting whispers back to Earth. No crew, no fuel, just light and speed. If it works, it would mark the first human attempt to truly touch another star. Project Longshot, a NASA and US Naval Academy concept in the 1980s, for a fusion-powered interstellar probe. Though never built, it laid out early engineering possibilities for autonomous star-traveling vessels. The dream of the generations. Some dreams are bigger than lifetimes. If we cannot travel faster than light, then we must plan for journeys that take centuries. Enter the concept of the generation ship, a vast spacecraft, self-sustaining, with artificial ecosystems, gravity via rotation, and cities inside hulls. Children would be born, grow up, grow old, and pass the mission on. Perhaps dozens of generations would live and die before reaching a new star. It is a heavy thought, but also beautiful. A society in motion, a world drifting through space, carrying human culture, science, music, love, from one star to the next. It would be a floating Earth, and maybe, in some distant future, one of those ships will arrive in a new system and plant the seed of life again. The biological challenge, traveling across stars, isn't just about machines. It's about us. Humans are delicate. We need gravity, protection from radiation, food, water, oxygen, mental stability. Space is not friendly. Beyond the solar system, cosmic rays and isolation become extreme. But advances in genetics, radiation shielding, artificial intelligence, bioregenerative systems may one day allow humans to live in space for centuries without needing to return. The line between biology and technology may blur. We may adapt to space, just as we adapted to Earth. Why we dream of the stars? We do not dream of stars because they are easy to reach. We dream because we are a species of seekers. We crossed deserts. We sailed oceans. We climbed mountains. We walked on the moon. Now, the stars call to us. Not with voices, but with silence. And in that silence, we place our hopes to survive, to explore, to understand, to endure. For in the end, space is not just out there. It is in us, and so now, as you close your eyes, know this: somewhere beyond Pluto, Voyager sails on, still speaking to Earth, with a signal so faint it takes hours to arrive. Behind it trail dreams. Ahead of it, the stars. You may never fly there yourself, but your mind can drift there now. Let it drift among suns never seen. Let the hum of light sails and golden records rock you into calm. Sleep, traveler. You are stardust dreaming of where it came from. You are Earth's whisper to the stars. And somewhere, the stars may one day whisper back, "Good night."